Let's wrap up this example by doing step 3. So far in this problem, we have parameterized the paraboloid and we have calculated big vector ds. The last step in finding the integral over s of f dotted with big vector ds is going to be to substitute in big F, big ds, carry out the dot product, set up the bounds, and integrate. So first of all, remember that f is equal to x, y, x, which I'm going to be dotting with big vector ds. So let's plug in. From our parameterization, we know that x is r cosine theta, y is r sine theta, and x again is r cosine theta. Big vector ds we calculated to be 2r squared cosine theta, 2r squared sine theta, and I don't need this part anymore. And r dr d theta. And down here, we said that for our bounds, r needs to go from 0 to 2, and theta needs to go from 0 to pi over 2. So now, let's carry out the dot product, and then we'll have a function to integrate. So we're integrating 0 to pi over 2, 0 to 2. For the dot product, we multiply the first components, which gives us 2r cubed cosine squared theta plus, multiplying the second components, 2r cubed sine squared theta. I like how that's looking. Plus r squared cosine theta. Now remember, when you dot two vectors, you get a function. You'll get a scalar quantity. So these three things are added together. This is no longer a vector. And then the first two, I see that I have my sine squared plus cosine squared. Those can be combined to give me 2r cubed. So the integral from 0 to pi over 2, integral 0 to 2 of 2r cubed plus r squared cosine theta. Now, in a lot of the examples we've done, we've been able to factor the function as a product of a function of one of the parameters times the other one, and then split the integral up. Notice that I cannot factor this as the product of a function of r and a function of theta. So I'll need to integrate with respect to r, plug in the endpoints and subtract, and then finish up by integrating with respect to theta. Integrating with respect to r, I will have 2/4 r to the fourth, so a half r to the fourth, plus 1/3 r cubed cosine theta, taken from r equals 0 to r equals 2. Plugging in the endpoints and subtracting, I get the integral from 0 to pi over 2 of 2 to the fourth is 16 over 2 is 8, plus 2 cubed gives me 8 over 3 cosine theta, minus, when I plug in r equals 0, I actually get 0 both times. So now let's integrate with respect to theta. The integral of 8 will be 8 theta plus 8/3. The integral of cosine theta is sine theta. and I take that from theta equals 0 to theta equals pi over 2, substituting theta equals pi over 2, I get 8 pi over 2, which is 4 pi, plus 8 thirds. Sine of pi over 2 is 1, minus 0, minus 0. So the value of this flux-type integral is 4 pi plus 8 thirds.